Hey, this is C. So on this differential equation, we're not given a function for y that we can substitute in. And so the way we're going to solve this one is by separating the variables and solving for y by integration. Now, I'm not going to spend a whole bunch of time going through that. This would happen. This is a natural log on this side. This is not. This is a power rule. So remember, if you have an exponent of y, so if I wrote this as y to the negative 1 and add 1 to the exponent, I get y to the 0, and then I divide by 0. Problem. So that one is a natural log. Any other exponent besides a negative 1 will work for the power rule when you're integrating. A little bit of reworking there. Remember, when you've got addition in an exponent, you can split that up into multiplication of two different bases. E to the c is still a constant. Plug in stuff, solve for c, and you get 5. And there's all that work. If you need to pause it and look at it longer, go for it. So you get to the end, and you have this equation for y. But the question is, what is the limit as x approaches infinity of that equation? So here's what you want to think. Start where the x is. As x gets bigger and bigger and bigger and bigger and bigger, what's going to happen to just this exponent? So negative 2 over 1,000, negative 2 over 1,000,000, negative 2 over 10 billion. What's that getting close to? So once you have that number in your mind, now ask yourself, okay, what's e to that number? E raised to the whatever this was. And now ask yourself, what's 5 times that number that I just got? So what's 5 times e raised to the blank? And that'll be the limit.